Hello everyone, and welcome to my new series, Lycan's Archeotech, where we discover old technology and explain it in a way that hopefully makes sense to you guys. This is a cathode ray tube television. Now you might be used to more plasticky sounds if you do that. This is a glass screen. Now you guys might be wondering, how did technology to create television exist in the 1920s? I mean, it was before any electronic circuits were really a thing. Well, to answer that, we have to look at the cathode ray tube. This is one from the 2000s, actually. How does this machine actually function? Well, to answer that, first we have to explain the name of the technology. CRT stands for cathode ray tube. What does that mean? Well, cathode rays are an early way of saying electrons. But the electron was discovered, and it was found that if you shot a wave of electrons at a phosphor-coated display, they would glow when exposed to the electrons. Thus, you have black and white TVs, which have only one real... They've got two things they got to worry about. Where the dot is they're putting on the screen, and we'll get to that, trust me. And then you also have to worry about the brightness. And early mechanical TVs just did brightness, and they tried to synchronize with the spinning thing. It was a whole nother mess. But how a cathode ray tube works is there's an electron gun in the back of this TV, which shoots the electrons. Normally they are aimed right here, but there are a bunch of electromagnets that move the beam across the screen. So they start from here, it goes across, sweeps, and then, you know, etc., etc., etc. But there are a couple of things you got to worry about, because back then bandwidth for television signals wasn't very big. So what you had to do was you had to reduce the frame rate to the point where it wouldn't cause stuttering and get out of the persistence of vision territory that made television watchable. You had to reduce the amount of information somehow. So interlacing was born. So it does first every even scan line, which is when the beam goes across the screen, and then it did every other scan line. So realistically, you have two fields, each of which happens 30 times a second. So you get an effective resolution of 60 frames per second, but realistically it's 30 for half the screen. And this is why when you blow up interlaced signals like an N64 or an NES or an SNES puts out onto a giant TV, something that takes these RCA cables, I'm sure you remember these. If you have something that takes the RCA and only does 480i resolution, then you're going to obviously see the scan lines, because the modern display is accepting a progressive scan signal and not an interlaced like this one. And also another thing to consider is you can't have too big of a screen, otherwise these things will get extremely heavy, because gravity loves to crush heavy things. Which means that this glass needs to be thicker the bigger the TV is. And considering that everything has to be scaled up and made even bigger thanks to a bigger screen, you have to have more room in the back, and you can kind of see where that can be a giant problem. So because flat panels can be lighter, they're thinner, now they're cheaper to produce, and they also are capable of higher resolutions. These things basically faded out of existence. And the main thing is, if you have too low resolutions, say you've got something that takes an RCA output, and you try to stick it into a giant flat panel TV, it'll look like absolute crap. I would know. I've tried to play an N64 on the giant 71-inch Ultra HD TV upstairs, and it did not work. With this, it looks like a charm. So perhaps a little demonstration of what this looks like is in order. Alright, so here we have the roommate's TV. We've got a Nintendo 64 here. We're going to set this to composite, and I'll show you just how bad this can possibly look. Might have to play with the exposure a little bit in the next demonstration, but everything looks really blurry with this. Daisy, Daisy,
your answer to. I'm half crazy, all for the love of you. It won't be a stylish marriage, I can't afford a carriage, but you look sweet upon the seat of a bicycle built for two.